This is lesson 2 of the algebra topic. This is looking at expanding algebraic expressions. Okay, so when we expand an expression, pretty much what we're doing is we're showing an extended version of a simplified expression. Okay, when I mean simplified expression, all that means is any expression that has brackets involved. Okay, so before we jump into the different examples that we get on this side, I want to show you a proof of what exactly is happening when we expand. So right here we can write and show a multiplication, which is 2 by 7 or 2 times 7, and obviously we know that this is equal to 14, but I'm visually showing you guys what this actually looks like. So we've got 2 down, and we have got 7 across, and the amount of little rectangles that we have here is 14. That's 2 times 7 is 14. Now, another way that we can write 2 times 7 is, and more specifically, another way we can write the number 7 is to write it as 3 plus 4. Okay, so I can write 7 as 3 plus 4 because we know that this is equal to 7. Okay, now there are many ways of writing 7, but this is just one random way that I want to show you of how to write 7. Okay, so when we rewrite this expression here, 2 by 7, I'm going to replace the 7 with a 3 plus 4. And what it will actually look like is not 2 times 7, but rather 2 times 3 plus 4. Now, visually, what's happening is we're getting 2 lots of 3, so 2 times 3, which is this first part here, and we're also getting 2 lots of 4, which is 2 by 4 here. Okay, so we're doing 2 lots of 3 and 2 lots of 4, and in order to get our answer, we just add the 2 together. So 2 lots of 3, 2 lots of 4. In other words, 2 times 3 is 6, and 2 times 4 is 8. Add them together, and we get 14, which is the initial answer that we started off with in the first place. So what this proof is showing is that this 2 by 7 can be written as 2 lots of 3 added to 2 lots of 4. And that's just one way. We can do 2 lots of 1 plus 2 lots of 6, or we can do 2 lots of 2 plus 2 lots of 5. This is just one of many ways. The proof that I'm trying to show you is whatever is on the outside of the actual bracket itself gets multiplied twice to the first term here and the second term here. So 2 lots of 3 plus 2 lots of 4. So this is what we call expanding out the bracket. Okay, now this is just an example of using numbers in itself, but then we can also do this with algebraic expression. Okay, so I'm going to leave this up on the side here, and on the right hand side here is where the examples are. Okay, so first example here is saying expand the following expression. In this case, we now have a variable or a letter, which is x, and we don't have a number. But the principle of expanding out still applies. So whatever's on the outside, remember there is an invisible times in between the 3 and the bracket. Whatever is on the outside here, we're going to multiply it with the first term, in this case 3 lots of x, and then also multiply it with the second term, 2. So this will be equal to whatever 3 times x is, plus whatever 3 times 2 is. And all we have to do is just a bit of algebra tidy up. 3 lots of x is just written as 3x, just a number next to the letter, and 3 lots of 2, in this case, is just 6. And that's all there is to it. Okay? So when we expand the following expression, multiply what's on the outside with the first term on the inside, and then multiply on the outside with the second term on the inside. And that's all there is to it, okay? So that's the first example. Second example, which is on the left-hand side, it's B. Again, what I like to do is I like to draw my arrows to indicate what's being multiplied with what. We just have to be careful now because we're dealing with negative signs, both on the outside and on the inside. So this is saying negative 9 times positive y, so negative 9 times y. Okay. That right there is just a times. Then we have a negative 9 times a negative 2. So I'm still going to write plus, okay? And just in case, I'm going to put brackets around here because it's going to get a little bit tricky when we have to deal with negative signs. So this is negative 9 times negative 2. Close bracket. Again, we just have to do a little bit of algebraic tidy up. Negative 9 times positive y will just give us negative 9y. And negative 9 times negative 2 will give us positive 18. Because when two negative numbers are multiplied together, will give us a positive answer. Okay. And because we've already got a positive here, we just keep it as positive. So plus 18. Okay, so our answer is negative 9y plus 18. Sometimes the answer in the back might show it the other way. So an alternative way is to write 18 take away 9y. These two answers here are exactly the same. So if you get this answer with this answer, it's still completely fine. All they've done is swapped the actual positionings of the numbers with their sign included. Okay? Cool. All right. Third example, we have a times 3a plus a times 2e. So multiply with the inside two terms, first one and second one. So the first one, this is equal to a times 3a plus a times 2t. Okay, a times 3 times a. Well, the number just still stays out because there's only one number, 3. And we've got a times a, which will give me a squared. Two lots of a, when multiplied together, will give me a squared. Hence what that 2 is for. There's two lots of them. And then we're just going to add a times 2 times t. The number always goes first. Then the letters, you can write TA or AT. It doesn't matter. Remember, the positionings of the letters, when they're multiplied with each other, they don't necessarily make a difference. You just got to be careful that the number, if we want to be mathematically correct, the number always goes out in the front. And the last example, we have a bit of a bigger example, a longer one. I'll just scroll this down just so I can have enough room. We have 2 times 3t plus 6, 3t plus 6 in the bracket, minus 5, 2 minus t within the bracket. So this is a bit of a bigger process, but that's okay. I want to write down what's being multiplied with 1. So those two there. And just so it doesn't get confusing, I'm just going to do an above arrow for the second one, because we've got two lots of the different expansions, and then afterwards we're going to tidy it up. So 2 times 3t, I'm just going to write straight into the next line. 2 times 3t, this is just 6, and then the letter t. 3 times 2 is 6. And 2 times 6, both positives, will give me 12. Negative 5 times positive 2 will give me negative 10. And negative 5 times negative t, so two negatives will give me a positive. and 5 times t is just 5t. Now, in a different color, I'm going to highlight the t's as they are like terms. And remember, in the previous exercises, we collected like terms. So this is a t, this is a t. They like each other, so they're like terms. This right here is just a number by itself and just a number by itself. So they are also considered as like terms. They're just numbers that are the same. 6t plus 5t is 11t, and 12 minus 10 will give us, have us be left with positive 2. And that right there will be our final answer. And that is it for this lesson, lesson 2, for exercise 1A expanding. I'm just going to get the log sheet popped up so you guys can have a look at what questions you need to do. Alright guys, here is the set log sheet. You guys are now on the second one, expanding. So it's exercise 1A from the textbook, page 7. If you're going to do the foundation questions, these are the set. If you're going to do standard, these are the set. And you're going to do advanced, these are the set. Now, I will say that if you worked really well with simplifying and you got the set foundation questions done early, my best advice is to actually work on the standard questions, okay? The only difference between this question 8 for foundation, standard, and advanced is what column you're going to do. And for question 9, there are different types. The advanced actually doesn't have any more questions to work on. So be true to yourself. If you want to do standard, or if you think you have the capabilities of doing standard, go ahead and do standard.